Each of us have been at this for more than 20 years, and we're tired. Tired of hearing people think that they have no hope, no future, and that they will simply sit in their cubicles and survive working in IT. Well, we're here to tell you right here, right now, that you can thrive in IT, and we are going to prove it.
Bringing you great stories
About great people in information technology
that it turns out are just like you. Welcome to THRIVEcast.
Hey, welcome to THRIVEcast. My name is DJ Eshelman, your host for the day, and I'll be bringing my co-host on in a moment. But anyway, I wanted to welcome you and tell you, if you are a person that is in information technology or wants to be in information technology and are wondering if there's something to this long term, well, we're here to tell you there absolutely is, and our guest today is going to absolutely prove that there are a ton of possibilities you might not even thought of when you're working in information technology. Speaking of possibilities, let me bring on Mr. Jeff Pitch.
It's possible he might be here.
Possible. The transition might be as weird as possible.
That's what I should have ducked down real quick.
Do the elevator thing.
Yeah, exactly. Oh yeah, I got to take off. Sorry, man. It's all good. Yeah, today's going to be fun. Benny's a great guy. People might have heard of him. He's been around a little bit, done a few things here and there, kind of obscure. But
actually, let's talk about that for a second. So, Dr. Benny Tritsch is self-employed, which is appealing to folks like us that are currently finding ourselves in that situation. Which is cool. So, but as a expert in user computing and that sort of thing, the area that we've spent the most time in, we can relate probably the most to. He's been doing a lot with workspace design. There's been a lot of work with graphics promoting, which is something we don't talk a lot about, as far as that being a key part of it that we take for granted these days. But there's been a lot of drama in that along the way. So,
I disagree. I don't think it's taken for granted because they're still expensive to throw into a server or get them into a virtual machine from a cost standpoint.
I meant the remoting part of it, the actual.
Oh, sorry.
Yeah, we need to talk about that more too. And
yeah,
absolutely. But as far as getting the point A to point B, that's what I'm talking about. So that's something that we take for granted these days, but has been a lot of drama along the way. So, but he has worked with lots of customers and partners all across Europe and the US. He's just one of those people that enjoys sharing his end user compute knowledge, which is one of the reasons why we love him so much. He has, let me get into this. He started his professional career in IT after receiving a Master's of Science degree in physics. And we want to talk a little bit about his research work at CERN. But in the 90s, it was much more of this, computer graphics research and things like that is where he received a PhD. Definitely have to talk about that in computer science in 1996. And so from 1999 on is when you and I probably were more likely to have met him, when he started in management positions at IT vendors and consulting companies, that sort of thing, before he started his own practice in 2015. So over the last decade, Benny has been awarded a Microsoft MVP, Citrix CTP. He's been VMware vExpert and EUC champion, NVIDIA Grid Community Advisor, which is really cool, Parallels VIPP, and you may have seen him at Microsoft events, Citrix events, VMworld, Bri Forum, our always favorite E2 EVC. He's worked for Visionab, he's worked for Immidio, he's worked for AppSense, Lakeside, FSLogix, Microsoft, and ControlUp. It's exhausting.
Not all at the same time, but
well, I don't know.
You never know, though. You never know with Benny. No, if people have been watching in the episodes, probably the last couple of months, well, a few months, Benny's name is intertwined with a lot of us.
Oh yeah.
With Visionab, I mean, we all, everyone talks about, oh yeah, Rick, he had the spreadsheet and all this, Rick Dillinger and all this stuff, but it's Benny is as interwoven into, I would say, a lot of our careers and memories and everything, as much or more so than a lot of people, and you may not even realize it. Like you said, Visionab during its time was huge. The Immidio stuff, all these things that gave us the abilities to do at that time what was a lot more difficult to do than it is now, in helping everybody along the way. So, if I make a joke, I made the joke about, hey, you may have heard of this guy, but it's, I don't know. It's weird because, I mean, for like me, I know him. I've known him for a while and all that, but it's all, he's not, I don't want this to sound off, but it's not a name that you hear a lot of people mention necessarily about the work that he's done and how fundamental and important that work has been to what the rest of us do. I mean, we all remember Rick for the spreadsheet and everything else, but Benny has done as much, or more over the course of his career. I mean, like you said, the GPU testing and all that stuff. I mean, that alone is so huge and so important. But that's what I got to say. I'm going to shut up now because
let's bring him on before he just is like, well, they're doing all the talking, so
he's probably falling asleep now. Just
he's like Jeff said it all. So anyway, let's welcome Dr. Benny Tritsch. How's it going, sir?
Hey. Nice to see you. Yeah, it's interesting listening to you guys talking about me. Amazing. Yeah, Jeff, and you're right. We've known each other since a long time, huh? It's 10 plus years, 15 years or so. Yeah.
Oh, at least. Yeah.
I still have pictures of you and I. Well, when we were attending the industry events and stuff like that. Yeah.
Yeah, sure.
Now, I'm trying. Were you at the Paris pub forum? Because I'm trying to remember when exactly we met, and I couldn't remember if you were there.
Yes, I was at the Paris pub forum, and
all right, there you go.
There were so many pub forums that I attended.
Well, but this was the last, I think, unofficial. Brian Madden first came over. I came. We were like the first Americans, and it was just the pub crawl. Not a pub crawl, but we had those drinks on the boat and talking, and it was just great stuff before Alex turned it into a more formal event.
I got to know Brian Madden at the pub forum in Munich, and we went to the Oktoberfest. So and it was like 15 or 20 of us. I don't know, more like 15. And Brian was very young at the time, and I thought, why is this kid here? So this is when I got to know him, and then later, I think it was only a year or so later that I got to know you.
Yeah.
So it's a long time ago. Yes, absolutely. Hey, thank you for inviting me to THRIVEcast. I'm thrilled.
Yeah, that's a lot of fun.
Beautiful. Thank you for that.
Oh yeah,
That's awesome.
We try to.
I love it. I love that you have it back there. That is so cool.
Yeah. Up leveling us now. We're like, oh man, I need to start doing stuff like that. Just have the virtual background and just kind of take your picture out of there, so you are actually the.
Yeah, I got so sick and tired of the virtual backgrounds, pretty much like you are. You're also using the natural backgrounds because they are so, I like them a lot more. But then you start arranging things in a background, like you also did, I suppose.
Yeah, but try to fine tune it and get what's right.
And I learn new things.
I can't move that closet though. That's kind of annoying me. But
yeah, I can help you. See the curtain?
Yeah,
that's the way.
Yeah, that's probably the next step.
Yeah.
So I learned a lot from looking how they do it in photo studios. So this is pretty much the setup that they have in photo studios.
Yeah, outstanding. Well, hey Benny, let's talk a little bit about like where you're from and kind of how you got started in early life and kind of build from there.
Yeah, I mean, I come from a family of craftsmen. I was born and raised in Germany, in the southwest part of Germany, so very close to the Swiss border, very close to the French border. One of my grandmothers, she comes from Switzerland, so 25% of my blood is Swiss. None of it is French, even though I was even closer to the French border than I was. I grew up closer to the French border than I grew up to the Swiss border. But this is the part in Germany where these three countries, they meet each other, basically. Yeah. And so it was so easy for me to go across the border, and it was just a natural thing for me when I grew up. And my father, he was a tiler. My mother, grandfather, cousins, they were dental laboratory technicians. And the other grandfather, he was a farmer and a metal worker. So none of them had a university degree or higher education or anything like that. So I grew up in an environment where building things with your hands was something that was appreciated or regarded as something that is desirable. Now, I always had the dream of doing something else. I always wanted to be a researcher or a scientist. And my grandfather, who was a dental laboratory technician, and he had started his own company. Unfortunately, he had to go to war in the Second World War. Because of that, he never was able to do what he ever wanted to do, because he always wanted to be a scientist or something. And I was basically the reincarnation of what he always was dreaming of. So he supported me early on when he figured, when he found out that I have a talent for that. So he introduced me to how transistors work and all these things, and he as a Christmas gift, he gave me an electronics construction kit. So I learned how to read circuit diagrams and to experiment. So that was my grandfather, as a matter of fact, and I owe him a lot. Because he would be 110 years old now. Wow. If he was still alive. But he died when he was 90. So he was very old when he died, because he had a very interesting life, as you can imagine, as a young man going to war and then coming back and trying to build up a life. He was one of the survivors. Fortunately, both my grandfathers had to go to war. Now that I'm working with an Israeli company, man, I was confronted with that fact a couple of times when I was in Israel, and the cab driver asked me, "Hey, where was your grandfather?" And I wouldn't want to lie. And I had interesting conversations with the Israeli cab drivers. Fortunately, my grandfathers were never in the higher ranks. They were like the soldiers who were sent to die. And they were fortunate enough to come back. That was the thing for me, how things worked for me when I was a kid. So they said, okay, do things with your hands, be creative, be responsible for your own life, because everything was destroyed and everything had to be built up. And when I was born, everything was already built up, but there was still this spirit of you are the master of your own fate. And so this was my dream, and I wanted to be on stage. I took theater classes when I was at school, and I wanted to travel internationally. These were the dreams that I had. So when I was happy enough, lucky enough that my family allowed me to go to high school until I had a certificate that allowed me to go to university. That was not the typical thing, because typically if you were born into a craftsman family, they don't want you to go for higher education. They want you to do real work, and they allowed me to go to high school until I was able to be an electrical engineering student. That was a natural thing, because like I said, I had to learn to read the circuit diagrams, and I learned how to experiment when I was 12, 13 years old, so very early on. And this electronic design skills was a door opener for something that changed my entire life, because as part of this being a student in electrical engineering, a requirement was to go for an internship, and I was able to get an internship at one of the the best research institutes, and that was the Fraunhofer Institutes for Physical Measurement Techniques. The mother of my girlfriend, she happened to know the head of this institute, and so she gave me his address, and I was able to apply for this internship. And guess what? They picked me because I was already able to do this electronic designs, and so I worked there. And I got a real formal education in producing analog and digital circuit diagrams, and produce printed circuit boards, and so layout designs, the routing and production of PCBs. So that was something that I learned in this 6-month internship, and that was extremely helpful. And the interesting thing was that the scientists told me, hey, if you stay in electrical engineering, that's probably not what you're good at. So maybe you should go for something else. And they encouraged me, because most of them, they were physicists, and they encouraged me to change my university and go for become a physics student. And so this is how I ended up in physics in Freiburg, in the city. We're very close to the city of Freiburg. I was born and raised. And so I went to university there. And as part of that, I learned so many new things. Then I was not a very brilliant physicist, to be honest. So math was not necessarily my thing. But I was able to make my way through it. I was more into the practical things, and this is what I always wanted to do. But the education as a physicist, I felt, was a very good foundation. And that's what people told me. If you're a physicist, you cannot do anything, but you're prepared for everything. Because you have all the foundational knowledge that you need to do whatever you want to do in science. And this is, like I said, this was always what I wanted to do. And when I was a student, I got exposed to my first computer. It was CP/M. And later MS-DOS as an operating system, so very early on. But then I did something that was unusual, even for the other students, and also for my parents and grandparents, because while I was a student and I was ready to start with my master thesis, I decided that I want to go on a trip around the Earth. So I bought, together with my girlfriend at the time, I bought an around the world ticket. And we started traveling east until we were back home. She was back home a little earlier, so I was traveling a little longer. So it took me 9 months before I was back at home. So one part of my dream came true, traveling internationally. And I was able to, through another Fraunhofer Institute, Fraunhofer Institute for Solar Energy Systems. That was also in Freiburg. They were the two institutes at the time. And I also worked for the Fraunhofer Institute for Solar Energy Systems. And they said, hey, we have this funny project in Nepal, and you're traveling to India and all these places. Can you stop over for 2 months and go to Nepal and to Kathmandu? Because we have this solar cooker project, and we don't have anybody who wants to go there. So don't you want to go there? So I said, hey, sure. Because my girlfriend, she studied medicine. She wanted to go to the hospital there. So we thought, hey, it's a good idea. She goes to the hospital and does an internship, and I go to this Royal Nepal Institute of Science and Technology, or no, Royal Nepal Academy of Science and Technology, RONAST. So that was the place where I ended up, and helped the scientists and researchers there to build solar cookers, so that they were able to cook stews without burning wood. Because wood is a critical thing, burning wood in the Himalaya. That was the thing, how I was exposed to both research and traveling internationally. So then I traveled on through, next thing was Thailand and Singapore and Indonesia, and then it was New Zealand, Cook Islands, Fiji Islands. In Fiji, I learned scuba diving. That was another thing I always wanted to do. Yeah. So it was one of the preferred dive spots on this planet, and that was the place where I learned scuba diving. And then I traveled to Canada and the US, and from there back home. And after 9 months, I was back home. I had no apartment, no car, nothing. All I had was in my backpack. So I had to get reestablished with the German society, with the German culture. And I can tell you, leaving home was easier than coming back.
Yes. Yeah, I always found that to be true. Yeah.
So that was amazing how hard it was to readapt to the behavior back at home. But then I was ready to do another international step, and so I tried to find something that I can do to put my master thesis together, because that was the final step. Right. And so I went from one department to the other in the physics faculty, and in the end I ended up in a department that worked at CERN in Geneva, this collider, one of the most spectacular places on this planet to go. And this is where I was able to go. And the reason was they wanted to have somebody who is able to create printed circuit boards. And the other thing is they wanted to have somebody who can go there and survive not being at home. I have a picture I want to show you, because I have a picture of my team and myself. So I'm the guy with the gray shirt, button shirt in the front, the black hair. Yeah, at the time I had black hair.
Almost kind of like a Steve Jobs looking there, right there, you know?
Yeah, a little bit, yeah. And here's a picture of the work conditions that we had. So it was like in a container, all equipment crammed into a container. And the kind of printed circuit boards I created, I found one. This is one of the printed circuit boards that I created at the time. And prior to that was rather the smaller ones that I had created. That's the kind I was able to dig them out. And this was my lab setup when I was a student. So this is how I made my money while I was a student, because at the time I started my first company to make some money because I didn't get too much money from my family. So my skills of producing printed circuit boards, that was what I did to make the money and earn the money for the around the world ticket. So you see here, this thing, this little aquarium in the back, that is the equipment that I used to do the edging
of the
printed circuit board. So I had the entire process worked out with a light table. I was also in the background. I built it myself, and then I created those layouts for the printed circuit boards and like photo process, and then developing that on the raw material, and then edging the printed circuit boards, and these were the early results of that. It's still not ready, and you see there were little mistakes, and I had editing was very tough because you had to produce this thing first, try it out, and then find out, oh, I missed one of the connections, and then you had to redo everything, go back to the table and fix it, and then produce the printed circuit board and build the entire thing and find out if it works or not. So this is what I did for a couple of years while I was a student. And there was a decision for me to be made. Do I continue that with my first company that I started when I was like 21 and stick with that for the rest of my life? That's a typical German thing. You start something and you stick with it for the rest of your life. And I decided, that's not what I want. And this is why I bought the Around the World ticket, because I wanted to get out of this treadmill, lose all my customers. I told them, hey, I'm going to be off for a year or so. And then I'm going to go for my master thesis. So that was the way to get out of this and do the master thesis at CERN, which was spectacular, I can tell you. Because, I mean, you have to imagine CERN is a place where like 50,000 physicists work, or 35,000, depending on who's on shift or who comes over.
Right.
And the experiment that I was working on was the Opal experiment. It was one of 4 experiments of the Large Collider.
Okay.
And there are physicists that built the collider, which is miles. It's a circle of miles. It's on one side it goes to the French and Swiss mountains, the Jura mountains. On the other side, it was the airport of Geneva. So they could not expand more because, number one, the granite was too hard under the mountains, right. And on the other side, the vibrations of the jet landings and was too much for the collider. So that was the natural size they could build this thing. Man. And put the 4 experiments at different places along the collider. And I was on one of these experiments. But to bring things into perspective, they took physicists to do all kinds of work. Like I said, they found out that I'm good at producing printed circuit boards.
Right.
And they found it easier to explain or to let physicists produce the equipment compared to explaining an electronical engineer or a software engineer how to produce these things that are required by physicists. So this is why you had this huge group of physicists from all around the world. And I would say in our group, we were like 300, 400 people working on this experiment. I would say not more than 10 people really knew what we were doing. And when I checked in at the hotel, because the CERN territory, it is between the French and the Swiss border, which sounds weird because the border does this. It's international territory, which allowed physicists from all over the world, even though there were physicists from Russia, and there was still the Cold War. So where can you work with physicists from Russia? There's no place on this planet. At the time, there was no place on this planet where this was possible to do, like American physicists, Russian physicists, Chinese physicists, and European physicists working together. That was only possible because you had this international territory, and we all worked there. It was like like a place where you cannot get out so easily.
I did not know that.
When I checked in at the hotel one day, I was standing next to Samuel Ting, a name that may not say much to you, but he's a Nobel Prize winner. So it was like standing next to a Nobel Prize winner, like, holy cow. That was the kind of caliber of people you were working with. And you learn very early on that only 2% of those people, like myself, doing a master thesis or a PhD, will survive there. It's the survival of the fittest. And what they do there is they try to identify if you have an extreme talent in physics. If not, what else can you do to contribute best to the team? So, okay, I brought in my skills producing these beautiful PCBs and doing all the electronics design. And then they wanted me to write the code for it, to look at what's happening on my device. And my device was responsible for managing or supervising the wires that are in the wire chamber. So our experiment was based on a drift chamber. You're shooting particles that nobody can see at particles that nobody can see. And when they collide, they produce like a mini black hole. It's like a Big Bang thing. Yeah. And then it creates a little bubble of energy. But energy cannot exist just without creating something else. So it creates particles that nobody can see. And then you're using drift chambers as like a gigantic photo. It's a photo. It's a camera. And it was a cylinder of like 20 feet long and 15 feet in diameter, and with wires. And these wires were some were charged and others were neutral, but they were only half an inch away from each other. So the reason why they did it is they wanted to create an electromagnetic field in there. So if there are charged particles that they bend, and you see these beautiful pictures sometimes on TV when they have these particle results, and this is exactly how this is made. I was a little part of building this huge camera and just supervising one type of these wires. And this took me 1.5 years to build and to write the software in C. They gave us the book, Koenig and Ritchie, and said, okay, now you're going to write your code in C. And the reason was all other physicists, they wrote code in Fortran at the time. But C was the only language that allowed us to read out each individual memory cell. And on the card that I built, that had a dual-sided memory and was reading out the voltage of each of these wires, and then compared it to what it was supposed to be. Because if these wires touch each other, well, a spark will be there. The problem is there was a flammable gas in there under high pressure. This means if my electronics wouldn't work, we would die in an eye blink. This is why I had to be very accurate. This is why they give one person this job, like 1.5 years, nothing else but looking at what the voltage is on the different wires. And if you shut down the whole thing, that it does it in a controlled way and not blow us up.
Big deal, right?
See, I thought you were going like I was the only person working on this because, hey, if it blows up, we don't lose more than one person.
Yeah, but there were other people like me who had to take care of that, and we looked at each other. So if you look at the design here of my PCB, it's not only my name on it; it's a name on another person, like it's another student, and it was like a peer reviewing that we did because we didn't want to die. And
when you talked about when you got there, and it was, what was the word you used? They like tried to find out where you fit in and stuff. I was picturing like Thunderdome type of thing, a little Mad Max. You guys get into a big cage match, and
it was a little bit like that. So after a while, you were able to see who got his talents where. And they were smart enough not to eliminate anybody. They said, okay, you came so far as a physics student. So, okay, you showed that you can do something, that you can learn something. But now we want you to help us to build this experiment. And I mean, there were hundreds or even thousands of people working at the collider or at the individual experiments. And typically it takes like between 5 and 10 years to build one of these experiments. And then you're using another 10 years to run the experiments and collect the data. That's a different kind of physicist. So I was always the one who built the experiments. I was always a builder without completely understanding what the theoretical physicists, what they wanted to find there. They predicted, hey, there's going to be this set boson at this energy. So now you built an experiment to produce this set boson. Before we built this, the collider, there have only been like 10 or 20 or 30 of these events where these set bosons were created. In the end, we were able to create one of these set bosons every second. And the camera fired every second. So creating a very high statistics, which allows you to, it's like Mythbusters. The theoretical physicists, they predict something, and then you have 1,000 people who built the experiment and find out, nah, not true. Unfortunately, go back to the drawing board, please. Sheldon Cooper, you start. So the theoretical physicists like Einstein or Stephen Hawking, they are the brilliant guys who have the idea, who make the predictions. And then it's people like myself who contribute a tiny little piece. And those who are head of the experiments, they, in the end, if they build something that is so brilliant, they receive a Nobel Prize. So it's not a standalone thing. Right. So these Nobel Prize winners, they are able to coordinate hundreds of other physicists to build something that has never been built before. And building the Opal experiment, that took 7 years. I was in a lucky situation that I was in the final group. So I saw the results. There were generations of physicists who never saw the thing working. Right. I was there when the first set boson was created and observed in the Opal detector, which was a breakthrough moment. 7 years of planning and building, and we were only delayed by 2 weeks. Can you imagine what kind of Gantt diagrams these projects leads had? And my boss, Rolf Hoyer, later became the general director of CERN. So he was basically my supervisor and the boss. And later he ran the entire place. So this is the kind of careers that you can make if you belong to this top 2%. I didn't belong to these people.
But still, that, I mean, like you said, it's a good example of, no matter how brilliant one person is, it takes, it takes a lot of people to make, Stephen Hawking. I mean, obviously he's a brilliant person.
Yes.
But all the people that it takes to prove that what he's thinking is right or wrong or whatever. I mean, that's, people, especially nowadays, people don't think about that. How long, I never knew it would take a decade to just create the experiment to prove those things.
If you're looking back, my experiment was taken apart in the 2000s. because then this period was over. Building for 10 years and using it for 10 years and then changing it a little bit. And then they built another experiment in the same pit because it's all down under earth and you work there. And because the accelerator is under the ground and then you have to go down and where the particles collide. And that's interesting that it's a 20-year period. And then there's the next generation. LHC, the Large Hadron Collider, that you may have heard of, and this is very interesting. That a professor, like my professor at the time, in his entire career, he can only do like a handful of these experiments.
That's amazing stuff. It really is. I mean, I could talk about this all day. I'm game. I think it's great. No,
I mean, that was the starting point because I got a brilliant education on how to develop C, and I started developing graphical user interfaces, having nothing else but set a pixel, draw a line, and write a character. That was all we had, and we wrote graphical user interfaces. Well, very primitive graphical user interfaces, but something that showed us the graphs for each of the wires, because I had to fine-tune the wires, so I needed to know what the voltage is and how they change over time and what happens when I shut down the machine. So many little of these graphs, one next to the other. And this is what I wrote in C, and I learned from the other students, because we exchanged the ideas how to set the pixel faster than we did before. So, and that was the interesting thing. For like half year or 9 months, all I did was programming C to read out the data from the hardware that I built.
Yeah,
and so amazing.
I got to imagine that there was a lot of failures along the way, a lot of boards that didn't work, a lot of things that didn't work. It's probably just setbacks.
I want to give you an example how this works. Just imagine that a spaceship lands on Earth, and they have like 10,000 like pieces of equipment that are 100% identical in their spaceship. So we are able to enter the spaceship and take one of these pieces of equipment and look at it. And we do not understand it because it's technology from outer space. We cannot open it. We don't have the tools to open it. The only thing that we find out is if we're shooting at it with a machine gun and it's being destroyed, that it creates a certain pattern on a canvas that's behind this thing. So in order to find out what it is and how it works, we bring theoretical physicists to the drawing board, and they make assumptions what it could be. Then they make a simulation what this pattern may look like if the equipment, this piece of equipment, is built in a certain way. And then we compare it to if we really shoot at it and destroy it, and can read from the pattern if there's a match or not. This is basically what particle physicists are doing. They're shooting stuff at each other, and from the pattern it creates, they're trying to find out how it works internally. It's completely out of whack if you think about it. And this is why it takes so long, and this is why it takes the theoretical physicists so long to come up with a new theory after some experimental physicists tell them, nah, not really.
Right.
My brain's starting to hurt. It really is, but this is so cool.
All right, I'll tell you what. Why don't we do this? We'll take a quick break, and we'll come back in about 2 minutes, give ourselves a quick chance to reset. And
sure. Next story after 2 minutes.
Yeah, so we'll be right back after these brief messages from me.
Meet Andrew. Andrew was recently promoted from an engineer to an architect. He knows the tech quite well. But now he finds that he needs to talk to management about their technology needs. But he feels like they don't necessarily trust him. They treat him like he doesn't know what he's talking about. Diane, the IT director, suggests that Andrew needs to learn how to better document and present to management. Andrew feels discouraged. he knows the tech very well, but that just isn't enough anymore. Should he resign? Go back to being an engineer? I have been there. It took several years of hardship before I finally unlocked the methods that I use today. The good news is, Andrew can learn them in less than 1 month and save years of trial and error. Now, Andrew is presenting in front of management, even the CEO. Don't tell him now, but soon he'll be offered a position at a vendor. Way to go, Andrew. You can do the same. Learn how to assess, present, and document so that the tech skills you've spent years developing shine.
Honestly, it's a lot of fun to put this together, but honestly, the thing about, I was just thinking about this yesterday morning, was just the difference in my career path and all these kind of things that came from learning these skill sets and putting them into practice. So these are things that, yes, I learned as a consultant, but a lot of people don't know that I actually I took some time as a consultant, traveling around, all that kind of stuff, but I needed a break. And so I actually took a job full-time at a company. And the difference in the way I applied things and the way the team was able to work from before I went into consulting, learning all this, and after was dramatic. And so these aren't just lessons for people that are in consulting. These are things that are useful in every aspect of your IT career. So that's why I expanded beyond the book and went way further into depth into this course. That's why I'm offering it to you. But because you're a THRIVEcast viewer, we have something special for you. We got $10 off this course. Go to thrive-it.com/TCAPD. That stands for THRIVEcast, Assess, Present, Design. I don't. It rolled off the tongue, easily enough. Anyway, go to thrive-it.com/TCAPD. Get $10 off that course, and let's get back into the actual smart people.
Smart person. I'm just an idiot now. That's all I know.
No. Like I told you, I was just a student, and they tried to figure out what they can do with the raw material. I was raw material, and that's good, because it was a game changer. Because in the past, when I was at school, they always tried to find out what I'm not good at. And when I was at CERN, they actually tried to find out what I'm good at, and told me, hey, if you continue doing that, if you learn more, you could really be very good. Not only like mediocre. No. You could be brilliant, but only in this particular thing. And they really helped me to find that where my talents is, because things that go easily for you may not go so easy for others, but you take it for granted. You're surprised that other people cannot do it. Like when I did the routing with the printed circuit boards, I thought everybody can do that, and then I learned that this routing, I did it in my head, because for me it was like a maze, and I was always good at this graphical thinking, but I didn't know. And so I was better than others when I did this routing, and I never knew that I'm better than others.
That's so key, and I think people need to hear that. People really need to hone in on that. Is that there are things that you do, and this is true for pretty much everybody, as far as I know. I've never encountered anyone that doesn't have at least something that's like this in their life. That it's easy for you, so you assume that it's easy for everyone else.
Yes.
And I assure you that it's not. And
I was hanging out with these physicists who were very good at doing these abstract thinking with math, and so that's not my thing. I'm a graphical thinker, so that's a contrast. So I was always struggling with those exams where I had to go down to this very abstract, formulas and stuff. Right. I really had to learn it like crazy so that I had enough routine to survive the exam. But I did not excel. But then when it came down to these other things that required the graphical thinking, wow, this came natural. And this is what I learned at CERN, and this is when I tried to find out what am I going to do next. I applied for a job at the Fraunhofer Institute for Computer Graphics. Because computer graphics, okay, now I knew that I was able to think in a graphical way. And one of my professors had told me, hey, there's this institute in Darmstadt. You better go there because they need new blood, and you would be great when you go there. And I applied for a job there, and guess what? I was accepted on a PhD program. Even though I was not a computer scientist, I was a physicist. But still, they said, okay, they looked at what I had done at CERN, and they said, okay, you are qualified perfectly to be a member of this PhD program. And that was wonderful to go to one of those research institutes. At the time, this Fraunhofer Institute for Computer Graphics was the largest institute for computer graphics on this planet. We had 300 full-time researchers working there, plus like 800, 900 students. So our institute was bigger than MIT Graphics Lab and all the others in the US together, combined. And this was the best place to go. And just because I did the C programming at CERN and like a little bit of graphics, and I had this experience traveling internationally, they said, wow, you are an ideal candidate. So this is how the things came together. I had never planned it. Absolutely not. So it was just looking out who wants to use these skills that I have. And I was lucky enough that they offered me this position on a PhD program. And I did that for 5 years because you only can have this kind of position for a couple of years. And the subject that I thought was interesting was graphics remoting, because we did a European funded project with distant learning in the 90s. And it was a time when the first browsers were built. As a matter of fact, while I was at CERN, Tim Berners-Lee invented the web. So he invented what we regard as the internet today, even though it was not the internet. It's just the web. And the reason was because the groups were so big at CERN, they wanted to have the authors that are when you write a white paper and you have so many authors because it's all the team members, and behind each author there was a link because you wanted to find out who contributed to what paper. And when you have thousands of physicists, you need to find a way. And this is how hyperlinks were invented. Very simple. And now you see what happened with that kind of technology. I never got to know him while I was at CERN because there were so many people. I got to know him later when I was at the Fraunhofer Institute for Computer Graphics because we were the hosts of one of the WWW conferences where Tim Berners-Lee came. So one of my heroes was there, and I got to know him personally. So from one CERN researcher to the other, while he stayed at CERN because he was so brilliant, and I was like the guy who was in computer graphics then. And my job was trying to figure out how we can do distant learning across countries and over long distances. And so that means to build something like a browser, create something like a remoting protocol. And through the WWW conference, I had the opportunity to speak to the developer of the Mosaic browser. He was sitting at my dinner table at home. And we had conversations about that because they were over at our institute, and we had this conversation. I invited him to my home. My wife and I were sitting there. And this is the book that was produced from my PhD thesis. And if you look in there, there are, maybe I find one or two, there are screenshots of Windows 3.11.
The fact that you brought up
like dialog box,
that's some memory right there.
Yeah.
Yeah.
So this is what it looked like. Because I had students who did the implementation in Unix, because computer graphics, that was dominated by Unix. And my boss said to me, my supervisor said to me, look, you're competing with the best of the best on this planet, because that was an institute where all the researchers from all over the world would come over and go for a PhD. And he said, now you are an outsider. You're competing with these best people in computer graphics on this planet. Now, you do something that you do better than all of them, or you do something that nobody does, and you are number one. And so I decided that I want to do the implementation based on Microsoft Windows that nobody did in the entire institute. They all did the Apple world, and they all did the Unix world. Yeah. Nobody took Windows seriously at the time. There was no TCP/IP protocol stack. I had to buy a third-party TCP/IP protocol stack because I wanted to talk to the Unix-based backend. And so yes, I had to build like sockets, communication sockets on TCP/IP using a third-party protocol stack. So this was real research that I did at the time, and we wanted to include multimedia. So I had students who implemented audio and video communication in real time. What we are doing now. Right. That was something that was part of my research work. And one of my students, she implemented motion JPEG for the first time. We were using JPEG compression, and then we, later became MPEG and all of that. So we were one of the first groups who implemented motion JPEG. And my idea was to introduce intermediate pictures to get a higher frame rate. And so that was a kind of research work that we did in the 90s. And when I had finished my work on that, and I was in the pipeline to go through the final exams, the internal IT department asked me if I want to join, because they said, oh, this Windows thing, that's going to be bigger and bigger, and we have nobody who knows it, and you did the programming, and we have researchers who want to learn how to program Windows. And now you see, I'm going to show you where I had learned everything. Windows API Bible. Wow. That is literally from the 80s and 90s. And I still have it standing here. And that was my Bible. So I learned that over all these years, how to program Windows. And then I educated the other researchers, and guess what happened? It took them like 2 months or 3 months to come to the point that took me like 2 years.
Right. Yeah.
So it was a good decision for me to be number one. Because they were so much better than I was, the younger ones. But since I was number one, I was the one who educated them.
There's a saying I've been using a lot lately, and that's that pioneers get shot, settlers get rich. You know,
yeah. That's true. And when you said that at the beginning, Jeff, I think you said it, that people don't really know what I contributed to all that. Sometimes I did some of the fundamental work, and you don't get the rewards for doing the fundamental work. Those people who create the multi-million-dollar products, those are the ones who get all the fame. And I was always in this early phase because I'm a scientist, I'm a researcher, I'm an engineer, and I love it. Right. There's always been that like that. And then Citrix came into the picture, because my job was to build a Windows infrastructure also for the Unix guys. And at the time, there was a product out there, an add-on product to Citrix that allowed you to create a multi-user Windows server based on Windows NT 3.51 and add the not the standard protocols like ICA, there was this,
you're blowing my mind with these memories, man. That is ICA. Yeah, it's I'm sorry. I'm thinking but it's all crazy.
So they had other protocol alternatives that allowed you to use Citrix combined with Unix.
Yep.
And X11 protocol was the keyword. And since I did that, I started diving into this technology, and I knew exactly how graphics remoting works, how these protocols work, because that was my PhD thesis. So
right.
Like writing encoders and decoders and like what this all means, what algorithms are behind that. I knew all that from my daily life over the last 4 or 5 years. And this is why it came naturally to me that I started establishing this multi-user Windows infrastructure. And there was another thing. One of my colleagues at the IT department, she was responsible for the video studio, because we also produced videos with the results. And she was the video editor and did the final cuts and everything. And her husband, he worked for a Citrix partner. And he encouraged me to do a training because I had hands-on experience. It was so funny because he made it sound when I started using this technology that everybody on this planet is already using Citrix, and the only one who's not, that's me. And he was a brilliant sales guy.
That is brilliant.
And I bought it. I believed him. In the end, he told me, yeah, you built one of the biggest Citrix environments that we ever had here in the German market. So thank you for that. So because we had enough people, we had the network, we had the graphics workstations and everything. We had like 1,000 people working with that. It was one of the most consumed services in the end, because the Unix developers and the departments using Unix, they wanted to create their documents in Word. And so what can you do? You can either put a PC on each researcher's desk, or you can allow them to access all the Windows applications through, well, remote desktop. Guess what? And that was one of the most popular services in this research institute. Okay, and I did the training classes, and I started writing books about it. So Windows 2000, I had documented everything that I did for the Fraunhofer Institute, and then I took this documentation and I sent it to publishers. And typically, a wannabe author goes to a publisher and says, "I want to write a book." I was one of these authors who said, "Hey, look, I already have this book.
There's a book here.
I want to publish it." That was kind of low-hanging fruit for them, and so they decided to let me do it in German first. And they asked me, "How many copies would you expect we sell?" And I said, "I don't know how many people are using this kind of technology. Maybe it's 500. And they said, our critical mass is like 1,000. If you're able to sell 1,000 copies of the book, then you're golden. This first book sold 1,500 copies. They said, "Wow, this is awesome. Only the German market. This is spectacular. Can you do the next one?" And this is what I did after I left the Fraunhofer Institute, and I joined this Citrix partner. So that was the way how I got into this Citrix world, like teaching the training classes while I was still at the Fraunhofer Institute. And I felt that I was not the right candidate to run a research group because I was too much hands-on, because I went out of a research group and into an IT department group, which most people thought, whoa! Now you're going down in your career. So it's not like the next step up; it's like a step down. But it was exactly what I wanted to do, to use all these skills in IT infrastructure. And remoting was the thing for me, because I knew so much about how it works under the hood. And this is why I started writing the books. This is why I joined the Citrix partner. GTS Graal was the name. They were the first platinum partner in Germany. And through the book writing, I got to know Mark Templeton. Guess how that worked? We were a platinum partner. Mark came to Germany because he wanted to pick up his new fancy car. And you know how that works. Picking up like Mark, driving the car to Hamburg, where it goes into a container and is shipped to the US. But driving on German Autobahn without speed limit. Okay, so in order to make it a business trip, he checked out which partners are on the way to Hamburg. So basically, he knocked at our door by email and said, "Hey, can I come by and hang out with you for a day or two?" We were like, "Holy shit, Mark Templeton is coming over." And so we went for a nice steak dinner in Frankfurt, and on the way back, I still remember it as if it was yesterday. Mark and we had a conversation. He was, that he's a great guy. I really love Mark Templeton. He's great. And so he asked me, "What are you doing?" And I'm writing on this book and Terminal Server, and he said, "Are there going to be chapters about Citrix?" I said, "Yeah, I was planning to have 1 or 2 chapters about Citrix as an extension. Don't you want to come over to meet with the team and learn from those who really do it?" And I said, "Wow, this would be awesome." And so he invited me to come over to Fort Lauderdale. And at the time, Bob Kruger was CTO. Jeff, you may remember Bob Kruger, the guy with the Hawaii shirts.
Yeah. Oh, yeah. Yep.
And I can tell you, he hated the idea. But he was only CTO, and his CEO told him, this Benny guy, he can come over and have a conversation with you guys. So this is how I ended up on Citrix campus. And I felt like traveling to the former Soviet Union because they gave me like an officer who was walking with me wherever I went because they didn't want me to look into the wrong things. And this officer, she was a female employee at Citrix, and she came from Germany originally, so she spoke German. And the only place where I could go without her was the restroom. All other places, she was watching me like it was crazy at the time because they were so scared that I steal their ideas. On the other side, they wanted me to write 2 chapters about their technology, though it was a weird situation. And fortunately, in the end, I ran into Brad Peterson, the one with the patents, not demo Brad, but the other one with the patents.
Yeah.
He was amazing because he said, "No, we cannot stay here on campus because here the walls have ears. Let's go and grab some dinner." And then for the first time, I got all the information that I needed. And he took out a little piece of paper and he started scribbling the entire architecture on this little piece of paper. I still have it somewhere. And so this is where I got all the background information on how Citrix works. And then, like I said earlier, I got to know Brian Madden right after that. And we both always had the ambition to learn how the technology works. Brian was always brilliant in writing it down. One day we were sitting next to each other on an airplane. And while I was reading all these white papers, because I can read in a diagonal way very rapidly, like extracting all the important points. And then I was sort of telling Brian, "Hey, this works like that." And at the same time, he was writing the blog article. He was always a brilliant writer. And so I was just throwing the ideas and the facts at him, and he was writing it while we were on an airplane for a couple of hours. So that was the thing that I learned from Brian, where his talent is like being able to digest these little bits and pieces of information, sometimes putting it together in the wrong way. And then sometimes I told him, "Well, the conclusions you're drawing from the facts that I gave you are wrong. and you wrote this blog article. He said, oh, I can apologize. That's no problem. I can say, no, I was wrong.
Yeah, it's easy to correct the blog.
I was like, no, this is not my style. My style is predictability, because this is what I was educated as a scientist. So only if you can reproduce the result in a different lab, then it's a valid result. If you just make up your mind, then it's not a valid result. No, not for Brian. So he was the one who was just shooting from the hip. But honestly, I learned so much from him, because we Germans, we tend to be over precise. I mean, look at a German car. You look at the cup holder in a German car. When you just pull out the cup holder, it behaves like you're looking at a Transformers movie. like 10 engineers who have worked like 2 years on only this mechanism behind the cup holder. This is German over-engineering. While the US, well, cup holder, what's the problem? And I mean, I was brought up in this German culture of over-engineer things, and then suddenly I was exposed to this American way of doing things. This was a cultural shock at the beginning, as you can imagine. But then I started enjoying it so much, and Brian was one of the biggest influencers in my career, definitely, because only watching him, how he's doing things and trying to adapt some of the things to my home market. Not everything works over here that works in the US, but it's very inspiring, actually. And then I started moving on with this background of writing the books. And Brian and I, we were competing here because ultimately I wrote the Windows Server 2003 book. Wonderful. I mean, I had started with Windows NT4. That was the first one. Then Windows 2000. And the breakthrough moment was here, because then the Microsoft Press asked me, can you write the English version, not only the German one? And that was the first time that a non-native English author was asked to translate the book to English instead of the other way around. And that was a massive breakthrough moment, because from that moment on, Brian, Matt, and I were competing, because he had the other book. He was the other author. And this is why we wanted to get to know each other. This is why they made us MVPs, because they also said, hey, we also want to have these book authors. And after Brian and I, after we knew each other for a while, we had this very intimate conversation about, hey, how many copies of your book did you sell? This is one of the best kept secrets typically. And then we found out that we sold about the same amount of copies. At the time, it was around 20,000, which was regarded as a bestseller in our market. And Amazon figured that out, and they bundled our books. So you were able to buy my book and his book at a discounted price. So basically, Amazon, they made us this team. And but the most spectacular thing for me was when Microsoft Press did that. They translated my book to Russian.
Wow.
So suddenly I was on the German-speaking market, on the entire English-speaking market, and on the Russian market. For me, that was one of the most spectacular moments in my life. And one of the Russian community members, when I was in Moscow and I did a project, he showed me the book. And I wasn't able to get one of those books, and he gave me his. So there's still some of his notes in this book.
Nice.
Typically, people ask me to sign their books, but in this case, he gave me his book with his notes.
That's crazy.
So this is why I'm still having this book here. And that was like, from that moment on, my career really took off. because suddenly I was known in the community, and then I also ran into Sean Bass, who was the other person that was extremely important for my career. And the thing with all the different companies that you mentioned, yes, I worked for Visionab. I worked for login consultants and helped them to spin off Immidio. I worked for AppSense. Then I started my own company. And then as an independent contractor, I worked for Lakeside. I worked for FSLogix, and now I'm working for ControlUp. And the thing is, it's always the same pattern, because you can imagine I had this conversation with my mom, because my mom asked me, I'm a little bit worried about you because every like 3 or 4 years you work for a different company. How come? This is not the German way, because she worked for one company her entire life. Yeah. And she said, why? After the third or fourth time, she was not so worried anymore. But at the beginning, she said, do they lay you off or what's happening? And I said, no, I'm only good for a certain phase within a company. What I learned is that I'm a startup guy, which is a very unusual thing for Germany. Germans, they hate risk. And being somebody who has to build stuff from scratch, yes, as long as it's engineering or something, fine. But computer industry, no. If you're not SAP, people do not understand what this means. But I started enjoying it because when I was at Visionab, we were a spin-off of one of the largest banks in Germany. And so I was part of the management team, and it was my job to identify those potential candidates that would become selling products. And because I speak developer speak and I know infrastructure, I was kind of the missing link. So basically, I walked from one developer desk to the next and asked the developers, hey, is there something that you've been working on that could be a candidate? And in the end, I created a short list of 10 potential products. In the end, we had like 2 or 3. And those were the products that were the success factor for Visionab. But after they had identified those products, they wanted me to shut up. Because they didn't want me to keep pushing. They said, now let us sell this here. Stop pushing. So the last thing that I sort of initiated was the Visionab remote desktop, which is interesting enough. I still see it sometimes out there in the wild.
Yeah, every now and then.
Yeah, and I developed that together with a Hungarian developer. So I created all the ideas, and he did the prototyping. Jeff, you may still remember him, Joseph Gorsas.
Yes.
This name may still ring a bell. I bought 5% of his company, so I still work with him. Because I really enjoyed working with him at Visionab, and we are working together until today. So it's long-standing relationships with outstanding people, because he can do stuff with code that I cannot do. Even if I originally was a developer, I looked at the stuff that he does. Absolutely not that I can do that. Absolutely not. He is a developer on a very different level. I can build a couple of prototypes, but he can build the real stuff. So nice. This is the kind of stuff that I learned. Bring the right people together. Be in all these companies at a very early stage. So login consultant, same thing. I helped them to get established as a consulting practice in Germany. Then I moved to the Netherlands, and I helped them to spin off Immidio, because they said, hey, you have done that with Visionab. You know how that works. Can you reproduce that? Okay, let's do that. Immidio in the end was acquired by VMware. Then AppSense asked me if I can join the when I asked them, why did you hire me? Oh, we have the plan to go public. And I said, aha, so you're hiring like the light heads in all the different regions. And I made a joke and I said, you just hired me because of my Twitter followers. And they looked at me and said, yes, exactly. That's the reason why. So I was like, I was joking. And they said, no. We need one of you guys in each territory to get the reputation and act as a door opener. And Goldman Sachs was the investor. Unfortunately, Goldman Sachs pulled the plug. And guess what? Who got fired? I was among that, like 30% of people who got laid off because I belonged to this IPO team. I was member of the office of CTO. At Immidio, I was CTO until I left because I did not agree with the strategy the CEO had. So I joined AppSense because they made me an offer that I could not refuse. And because they wanted to go public. Then that stopped immediately. Yeah. I mean, I was, as a European, that's a situation that we are never exposed to, getting laid off within 24 hours. So my boss, Keith Turnbull, who was head of development at Citrix earlier, so he was head of development at AppSense. I was a direct report. So he came over to Frankfurt, invited me to the airport, and gave me the pink slip. And I said, I have a German contract. It doesn't work that way. And he said, yes, I know, and you know, but our new CEO in the US, he has no clue. He has no idea. So I have two choices. Either I'm going to lay you off today, or they're going to lay me off tonight. Oh, okay. And he wanted to stay with AppSense until he retires. So he asked me just to accept it. And I said, I'm going to sue the company. And he said, yes, absolutely. You have to. Because it's not the right thing to do. And I always enjoyed working with you, but that's my job now. It was interesting to tell my wife because I said to her, either I get promoted when I go to the airport or they're going to fire me. And she said, they cannot fire you. I came back and I said, guess what? I just got fired. And she said, holy cow.
I'm pretty sure cow was probably not the word that she used. But yeah, that was a really strange time because I mean, like,
truly,
everybody. I mean, like all the big execs, everybody got. I mean, and you're right. It was like overnight.
Yes,
that suddenly everything changed for AppSense. Yeah. I mean,
the money was gone.
Yeah,
it was a lot of money that Goldman Sachs put into the company, and suddenly this money was gone. And Goldman Sachs said, no, it's not going to happen. It was a plan over 4 years, and exactly after 2 years, they did a review, and they said, no, it's not going to work. It's not the numbers. It's not the graph that we want to see. It's not the hockey stick. It's not happening. Yep. So,
yeah,
that was it.
Yep. Yeah, because I remember that. Yeah, they went on a huge hiring spree.
Yeah.
And then that was crazy.
Yeah, but I mean, this was the period where I was able to work with all these brilliant people in our industry: Rick Dellinger, Brian Madden, Ron Oglesby, and then Sean Bass. Because Sean Bass and we decided that we want to explain to people how remoting protocols really work, because Sean also has a very strong background as a developer, like I have. And the Microsoft product team, when they presented at Briforum or E2E, they were using the developer jargon that people would not understand.
Right.
So Sean and we talked after one of the sessions that Nellie Porter, at the time she was group program manager at the RDS team, she did a brilliant session, but only Sean and I probably understood what she was talking about. The rest of the audience was like, what? And Sean and we decided that we want to explain to the others what she was talking about. Like, being the translator or the interpreter. And this is how we came up with doing all the protocol testing, because at the beginning we did that in a rather theoretical way. And people said, whoa, I do not understand what the effects are when you modify the protocol in such a way. Is there a way you can show us? And sure enough, we cannot bring our demo systems with us. So, and Brian at the time, he used frame grabbers. So, Jeff, do you remember the Epiphone frame grabbers? This is what they look like today.
Yeah.
I'm still using them. The new generation of the frame grabbers, they used to look very different.
Oh, yeah.
And, Sean and I, we bought those frame grabbers. We ran the experiments in our labs, and we presented the videos of the results. And we thought this would be only something that we do once. And then we learned that if we do that over a half year or a year and we have new findings, that we have a fan base that would come back to our sessions and just watch our session. And when we ask the attendees, well, you have seen this session last year, why are you here? And they said, well, it only takes me 45 minutes or 60 minutes to learn what would take me months to find out myself. I know exactly how your methodology works. I know that you are scientists, you are researchers, so it's not some BS, it's real. Yeah. And so we can take it for granted. We can trust that these are correct results. I mean, we did the same thing that I learned at CERN, build an experiment and make it reproducible. And this is what Sean and I did. And Sean is such a brilliant mind. I mean, I always said that I have the PhD, but he's got the brains. Seriously, he is outstanding. I've never seen anybody who's able to pick up new things so rapidly and present it in such high speed.
Yeah. Well, and always with that sense of, it's not like disloyalty, but at the same time, it was like, this is the facts. This is what we found.
Yes.
And it wasn't sugar-coated. It was like, no, this is truth.
And the thing that we learned is if you combine a European researcher using, the methodology, the old-fashioned methodology, and an American speaker who is able to articulate things in a good way, and both Brian and Sean were able to do that. So this is why I always enjoyed presenting with them. And so we were able to get this message out and have the real facts behind it. And this is what I'm still doing. I'm still into benchmarking. I'm still into like comparing stuff like side by side, because this is something that the human brain can process a lot more easily than other things. And thanks to Brian, we had learned how to use frame grabbers, and we took it to a whole new level from there, together with developers, together with other industry experts. Like Esther Bartle and Frank Berson and Ruben Sprout. I did many presentations together with Ruben Sprout, who is another.
He said a hi earlier. I don't know if you got that, but
he's a great person, and I always enjoyed working with him on these experiments and presenting the results. And the other thing is going from one company to the next when they are in their early stage as a company, or if they want to enter the German-speaking market, because our business culture is so fundamentally different to the US business culture. If you do not adapt your product to that, then you're not going to be successful. And since I've worked for US companies, companies in the UK, in the Netherlands, and now in Israel, I know the different business cultures in these countries, firsthand experience. And so I'm able to tell or to advise those companies how to win the market. Now, the thing is, as soon as this particular market segment is worth more than a couple of $1 million, it's time for me to move on. And that's exactly what I said to my mom. I said, I'm a builder. I'm not a maintainer. I can envision stuff, what it looks like in a year or two from now. And I've learned from early childhood to build it. Now, after it's there, it's not so attractive for me anymore, to be honest with you. Yes, I can do it. I did it once. I can do it twice, but third time, fourth time, it's not so interesting for me, to be very honest. So I'm not patient enough. When I was young, I always wanted to be a CEO of a company that, goes public or stuff like that. My education at Fraunhofer Institute, that was exactly geared at that, to become like a leader in one of those organizations. And some of those people that were on the PhD program together with me, they actually made it. No, I personally enjoy this being at a very early stage, hands-on, technical, and that is something that I enjoy so much. And working together with all these talented people in our industry, that inspires me, to be very honest with you. And I mean, another one that I want to mention is Jim Moyle, because when I worked at FSLogix, Jim Moyle was my counterpart in the UK, and so we had the opportunity to work on the same things together. And then when we were stuck in the US from one event to the next, and we had a weekend to kill, we found out that we both love scuba diving. So we are both advanced scuba divers. So we did a couple of dives together, for example, in Florida, in the Keys. So we rented a house for a week, and we went scuba diving in Florida. And the other thing is we both enjoy riding motorbikes. So when we were in Utah for a company meeting, FSLogix company meeting, and we had a weekend to kill, we rented motorbikes, and we enjoyed very much being together on these rides. And I was at his wedding, and so our families know each other. So this is something. The same is true for Sean's family, for Ruben's family. Esther, for example, she came over here. So we know each other quite well, and this is what I enjoy most. So this is why I never wanted to be one of these big shots in a large organization. I enjoy a lot more this community life. That's my now in my late 50s now. I mean, I'm doing that since 30 years now, and I'm still enjoying it as if it was my first day.
Yeah, that's important to get things to the point where it's like, okay, it doesn't become just rote. It just doesn't become like repetitive or whatever. It becomes interesting. Yeah. And that's kind of the beauty of maintaining a level of independence, is that you can change things up and not lose everything you have.
I mean, when I was at FSLogix, Microsoft acquired us, and I had a contract for a year at Microsoft because they acquired us, not only the assets but also the people. And the field team, they gave all the field team members a 1-year contract. And Jim, for example, he stayed, and he's doing a great job there. And Christian Brinkhoff, he stayed, and so these are the people from this team who stayed. I decided that I rather want to move on and go back to these startup style companies. And ControlUp, I had interesting conversations with Yoni over the years, and he said, we want to get established in the German-speaking market, so we want to hire you. So I always try to be the hire number one, or as a contractor, because there's no legal entity, so they cannot really hire me, but they can give me a contract. So as a contractor, and this is what I'm doing part-time. And this is the other thing, the next roller coaster ride. And as soon as it's big enough, because now we already have 10 or 12 people working for us in the German-speaking market, maybe in a year from now, it's time for me to move on to the next startup. Yeah, and this is what worked out well for me, and which makes me happy. I had offers from these large cloud providers, public cloud providers. They offered me positions with a shitload of money, but money is not everything, to be honest with you. I really enjoy this independent work. If there was a right offer in the right position, maybe I would do it for a while. But right now, and my wife says, hey, as long as you are happy. And I mean, we're still paid well in this industry. We're in the lucky situation that it's an industry that pays well. So even if you're not making the highest salary, you can still have a happy life, and this is what I prefer. And I can still be an engineer.
Yeah, and you do crazy things like start YouTube channels and
exactly, without asking anybody.
Exactly. Yeah, that's the thing. I don't have to ask permission. I just do it.
It's funny you bring that up, because somebody that I'm trying to get on, and I'm waiting for the hear back from them, has to go to their employer to find out if it's okay for them to be on. Yeah.
And I always had this conversation. Why are you on these community programs? And because you're doing that during the time when you're supposed to work for us. And now that I'm independent since almost 6 years now, this investment comes back. Yeah. Yes, even though I had to pay for flights and hotel myself, it still made a lot of sense. I actually had interesting conversation with the at customs in the U.S. when I was entering the U.S. The customs officer or they were asking me, why are you coming over here? Yeah, I'm doing a presentation here. Are you getting paid for that? Because then it's illegal. We're going to send you back with the next airplane. No. They don't pay me for that. Why in the world would you do that? Why would you come to the U.S. and present in front of a U.S. audience for free? And I said, because that's my marketing, because they're going to record it. It's going to be on YouTube. And then people are going to reach out to me. And as long as I work from Germany, I can have U.S. customers. I cannot come on site into the U.S. And that is the last story that I have for you today, when I said it's beneficial if you work together as a European and a U.S. citizen, because we have fundamentally different legal systems. And the person who told me first was Ron Oglesby, because when he wrote his VMware book, VMware tried to prevent him from doing benchmarking. Yeah. So he said, hey, look at the ULAs. The ULAs tell me I cannot do benchmarking. And I said, this is different in Europe, because we do not buy the right to use something. We buy the license. We own the license. And it's like buying or renting something. When you rent something, you cannot do stupid things. When you buy it, I mean, you buy a car, you smash it into a wall. Yeah, sure, you can do that. But the rental car, no, maybe not. And since we own everything, we can do with whatever we want to. That is covered by European laws. So Ron said to me, can you reproduce my benchmarks and give me the results? Because I can use the results that were collected in Europe. I said, sure enough. And then later, when Sean and I worked together on the benchmarking, we always published pictures where Sean is either sitting in my lab, or we brought the entire equipment to a hotel room in Germany or in Europe, and having evidence that we collected this information in Europe, because then it was totally legal, and none of the big vendors was able to sue us. And that was the thing that we figured out, how we can work together like guerrilla tactics. We just take the legal system that is good for us. I mean, all these international organizations are doing that on a very small scale. We in the international community can do exactly the same thing. Start companies wherever it's good for us. collect information wherever it's good for us from a legal perspective, and then use it from the territory that, helps us doing that and does not prevent us from doing that.
Yeah.
So this is a very, very important lesson that I've learned over the last 10, 15 years. If we work together, that's much stronger.
That's a big lesson to learn too. Because that's very different.
And the US, sure. I tell you, Ron Oglesby was the one who was the one who opened our eyes.
But when you're used to something being that way, like you were, over in Germany, and it's an American company, you think, oh, that's probably, the licensing, blah, 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 is all going to be the same, but
nope,
it's not.
I mean, we have a second-hand market for software licenses. This is totally legal over here.
Yeah.
It's completely illegal in the US.
I remember my step or ex-stepdad, whatever, family tree's all messed up. Good friend of mine. They were a Novell NetWare partner, and they would resell. At the time, they were able to resell the NetWare licenses.
Yes,
they had a separate company set up. Yep. That when people got rid of their licenses or dropped, they were able to resell them and whatnot. And then Microsoft came along and ruined that market in the US. So. I didn't say that, did I? Huh? What?
Yeah, so this is why I'm always trying to figure out what's new, what's happening in the EUC market, because that's my thing. I want to stay in the EUC market. It was never the thing that I intended when I did my PhD. Just right. Think about it. Yeah. You said it, 96. And since 25 years, I'm doing that kind of stuff. I never had the intention to do that basically my entire career. But things were changing so rapidly over all these years, and it was always attractive staying in there. And now with Azure Virtual Desktop and all these things, suddenly we're in the center of the universe. We always were dreaming of being a part of this inner circle. We were always, it's like in we were Star Wars, when you are in the outer rim of the galaxy, and then suddenly you are a Jedi. And sometimes I feel like that.
It's really true. I mean, and I've said it before, it's like, oh my God, Microsoft is taking terminal services serious finally after 25 years. It's just crazy stuff like that. Yeah, you're absolutely right.
And okay, so this is why EUC industry is the thing that I love. Always trying to find those companies that want to do something new and help them to get established. In the FSLogix case, I was one of the investors. So I learned that I should have my shares early enough. That's another hard lesson that I learned, because otherwise people benefit of the ideas that I have and I contribute. And ever since I ask for shares, options, whatever. And then it's something, and I take lower daily rates. That's fine. But if things, are working well, I want to have my share. And that worked so well at FSLogix. That was an experience of a lifetime. I will tell my grandchildren when we got acquired by Microsoft, because as an investor, you are part of all these interesting meetings. And Jim and I, we were those Europeans that were in the last round of negotiations, which was very interesting, with 15 Microsoft lawyers on a call.
Yeah, I've heard some of those horror stories, and yeah, I'm glad you got through it okay.
Yeah, absolutely. I cannot retire at this stage, so it's not that I'm as rich as those who founded the company. Absolutely, but
that's what they would anyway.
It's good enough to I'm able to take another risk, so that is the thing that's nice for me.
Well, I tell you what, gentlemen, let's take a quick break, and then we're gonna get final thoughts from Benny before we go. So we'll be right back right after this.
Thank you.
If I can hit the button. There we go.
This is Edward.
Hi there.
Edward is an IT systems engineer at Healthy Hospital. He has his eye on a job as an architect. But there is a problem. He is days away from being fired. Why? Because he has a hero complex.
Wait, a what?
A hero complex. Seriously, I have the most clear voice on the entire internet, dude.
Sorry, but what is a hero complex? I thought being a hero was a good thing.
It is good to be the hero, but when you fail to do your project work because you are troubleshooting issues for people that others could be doing, that is a hero complex. You are trying to feel good about yourself, but you are only hurting your career.
I had no idea.
Of course you didn't. No one told you. No one taught that to you. Until now, visit thrive-it.com/elevate to enroll in a course that will teach you how to properly approach your peers and your superiors. Now you'll be able to be the hero they need, not just the hero you think you should be. thrive-it.com/elevate. Do it now.
And again, Ken's course is available, thrive-it.com/elevate, until the end of this month. If you're viewing this live or replay that within the time frame, you're going to get a great deal. So get on that now. But it's still okay if you've enrolled in it. If you don't like saving money, it's fine. But great feedback from that course. It's been great to teach people more of the soft skills, the kind of how to deal with people and how to just run things from a human perspective, not just here's the technical skills and all the things you need to know. So highly recommend that. Thank you, Ken, for being an affiliate, and thank you for supporting this show with that as well. So let's get back into final thoughts with Dr. Benny Tritsch. All right.
It's
Great
so funny
show.
when you say Dr. Benny Tritsch, because sometimes when people ask, "Hey, is that real?" I said, "Yes, I'm a real doctor."
Yeah.
And at CERN, there was a funny anecdote because once per week we were able to watch movies there in one of the largest lecture rooms. And one night there was Ghostbusters on, and the best moment was when Bill Murray says to Sigourney Weaver, "Trust me, I'm a scientist." An entire room full of nerds. And she says that, and she was hot at the time, and everybody was like, "Oh yes, trust me, I'm a scientist."
I love it. Awesome stuff. Well, Betty, I mean, I also love the fact, by the way, just to point this out, that you both have last names that are very similar, and so it's like the Tritsch and Pitch show.
My family's German, very strong German. And
yeah, the SCH is a strong indicator.
Uber German, yeah.
Yep. In fact, it was my great grandparents that came over from Germany. Either that or it was their parent, but either way, yes, very.
Yeah, and mine were actually Germans from Russia, so that kind of
okay.
That's a weird little escape kind of thing going on there.
Yeah, that was complicated things.
It's been a weird century or so. Yeah.
Yes.
Well, Benny, any final thoughts for our audience today?
I mean, a couple of years ago, I thought that the EUC industry is not so attractive anymore, and I turned out to be so wrong. Like we discussed earlier, that now that Microsoft found out, we have remote desktop services and we should do something about it. And when I was part of the Microsoft team, I was part of the RDS team. And I do not share a secret that they were not regarded as one of the most interesting departments in Microsoft. But then they figured that even though there was no official offering for remote desktops in Azure, there was a substantial percentage of Azure consumption produced by people remoting into desktops. And they thought, whoa, if we generate that kind of revenue without a technology behind it, without marketing, without anything, maybe there is a market. And then they figured it's going to take longer than expected to migrate people away from Windows applications. So personally, I see Windows as a runtime environment, nothing more, nothing less. And it's got all the plumbing that is required to have Windows applications communicate with each other. And that's basically what it is. Reduce it to a runtime environment for applications that can be very feature rich and can be very graphics intensive, coming back to this GPU accelerated thing. Yeah. And so I think it's even more important than ever before, because it's really hard to migrate all these applications that exist today, line of business applications, to native web or mobile applications. All the low-hanging fruit has already been done, and it's going to take a while until all the others are also catching up. And now I learn a lot more about containerizing everything. So like Docker containers and infrastructure as a service like Terraform and Ansible and all these things. Those are the topics that I focus on, and going back to Visual Studio and developing in C# and all of that, so that all these worlds come together. This is what makes me excited in our world. So it's not looking back and thinking, okay, we're gonna do like in the old times with the hosts, that we're gonna do host technology for another 10 years just because it's still there. No, it's still developing. It's still new stuff that is happening there, and that makes it attractive. I would not recommend that if somebody comes from university today, that he or she should go into the EUC industry, because I would say it's going to end in like 10 or probably 15 years and be replaced by more modern technologies. But that's good enough for me for making money in this industry for another 10 years. Sounds good to me. These are the final thoughts. My son, he is 24 now, my older son. And I would not recommend that he follows my path because he needs to find his own path. So that is sort of the final thoughts that I have about. And I always enjoyed being among the first, doing a couple of things. And I had this rare opportunity to be like an eyewitness of some of these things when they really happened. I was at CERN when the web was invented. I was part of this group that worked in research when remoting and video conferencing was invented. And I'm very proud of this, to be very honest. I'm very happy about the opportunity that these people gave me, who thought that my talent could be useful as one of the stones, one piece in the puzzle. And this is how I see myself, a piece in the puzzle, and together with you guys, to be very honest. And I enjoy this community so much. Hey, Ruben, he's on holidays, and even though he's on holidays, he dialed in. So thank you, Ruben, for that. What are your thoughts?
It's funny. I've had a lot of the same thoughts that you're thinking about EUC, although I think it's going to take longer.
Okay.
Just based on, because remember we were all supposed to be running web apps, web front end.
Yep.
Things don't change as rapidly as we would like. And Windows apps, just from the standpoint of we still have Windows 2000 servers out there running mission critical applications for companies. And those are the things that it's going to happen. I just don't think, I wish it would happen faster, but yeah, hey, I'm disagreeing with Benny, which means I'm probably going to be wrong.
I think it's going to take longer.
But yeah, no, it's always interesting. And I would love to chat with you someday about that containerization stuff. I said that totally wrong. Yeah. But because I had an interesting discussion actually with the Microsoft team on that. I'd love to get your thoughts on that. Yeah. So.
And the other thing is the benchmarking. I created a website called eucscore.com, and like all these synthetic workloads, I decided to give them away for free. So now I want to create the version that is stable enough to just give people access to that, because I decided that kind of want to spread the word and contribute to the community so that other people can do the kind of synthetic stress testing of their environments. I've invested like 3 years of development time into that, but it's not all the tools behind that. That's something that we may not give away for free, but the workloads, this is something that I decided that I want to sort of contribute it to the community so that people can start from common ground, because that's always the conversation that I have with some customers. Hey, how can I find out how good the quality, how good user experience is? And it's not an easy thing. That would cover another hour or so if we talked about user experience, but then it's back to technology. And here I thought we got to talk about, hey, why did I end up in EUC?
And I think you're planting seeds for the next generation to come along and do their testing. Not keeping everything.
Being a mentor. Yes, I enjoy being a mentor and having younger people like myself and help them to get established, sometimes with presentations, sometimes with the technology, just to educate them. So this is what I want to do over the next years, so that I can hand over more and more of the stuff that I'm doing to younger people. Unfortunately, we have not so many young people who are entering our market. So it's all seasoned experts. I mean, most of us are in the 40s or 50s. So when I look at Carl Webster, he's in his 60s, and he said he's the accidental Citrix admin, and I have the impression I'm the accidental EUC expert.
But you do. Yeah, it's a weird dichotomy there, because EUC as we know it is changing. I don't want to say going away, but is changing to the point that we're not going to need, I think, necessarily people like us over the long term. I mean, that's now that Microsoft has really, truly jumped in the game, that's changing. And so it's hard to get, as I center myself in my camera, it's hard to get the young people into it, but yet we still really need people.
I had exactly this conversation with my son. It's funny because I had asked him sometimes to help me with some of the projects, and then I told him what I want him to do, and I took some of the stuff for granted that he knows, and he said, "Wow, Dad, you're doing that since 25 years, and you know all the basic stuff. I don't." And so you're talking over my head, even though I'm in IT industry. So that is, and now we find new customers, because now it's a broader market, and we end up in conversations, in the same sort of conversations that we had 20 years ago, where people are like, "Wow, you can remote into Windows applications," and we are like, "Yep." And wow, I've never seen that. And I tend not to answer under what rock did you live the last 20 years?
When you because it's not fair. But when you think about the penetration over the last 20 years into enterprises, it's always been a low percentage. So I mean, most
we were a little niche market.
A
little niche market.
Now we're not.
Yes, and that's exactly it.
Yeah, that's a big reason why the attitude is much more thinking in terms of working in IT services, not just EUC or not just
that is correct
programming, not just one aspect of this. We're expanding that quite a bit these days. It's a big
and I think the great thing about what we do is it's not just EUC, it's not just end user computing, because you have to know so much around what makes end user computing happen. You can't just know Azure Virtual Desktop or Citrix or VMware Horizon. You have to know.
If you look at Citrix, you need to know how a database works, because there's a database attached to it. So how can we make that, design that in a good way so that it works for the customer? Then they have a web front end. Okay, so we have a conversation about web technology and so on and so forth. You can go from one step to the next. Then you have a virtual appliance, which is based on a Linux OS. And so certainly you talk Linux to customers. And I agree. I totally agree with you. You always have to go beyond the core technology that's behind EUC. And this is only possible if you work in teams, because it's impossible that one of us knows all of that. How you hook into Active Directory, how authentication works, how security works, how compression algorithms and encryption algorithms work, and all of that. So you need an expert for each one of those. Otherwise, you won't get it up and running at customers. So that's what I learned.
Yeah.
That's right. Cool. Well, Benny, thanks so much for being with us today. We really appreciate you. And
I enjoyed that so much.
Yeah, it's been great to, it's fun to hear all the stories and all the background, the behind the scenes stuff like that. So we really appreciate you giving some perspective to people and telling your story. So we appreciate it.
Thank you so much for having me.
Cool. Well, we'll send you back to the room. We'll be back with you in just a moment. All right, Jeff. Final thoughts.
You got my link there, because okay, so as we're talking about CERN and physics and all that stuff, so to go nerd, unfortunately, this is probably not a geek thing. I am a huge fan of the show Teen Titans Go. It is hilarious because it pokes fun at everything. But there is an episode where Robin, we must live in the Matrix, blah, blah, blah. He wants to teach the other Titans about physics and reality and things. And the team that creates the show came up with a rap about quantum mechanics, quantum physics, or quantum physics. And it's hilarious. It's great. It cracks me up. So that's the link to it. I would love to show it right now, but I'm also pretty sure we'd get shut down as we're showing it. But that's the YouTube link. It's just a minute's worth. It is hilarious and awesome, and you learn something. So there you go. Cool. That's my final thought.
All right.
Go have a laugh.
Right on. All right. Well, thanks for everybody for being with us today. We really appreciate your time, your attention, and your willingness to learn and adapt. So it's so important. And that is my final thought for today. It is really important to recognize that everyone has talent areas that they may not think are all that special, but they totally are. And so get out there, discover what those are, and absolutely live within those. So whatever that means, there's so much that you can do in the IT industry. So find out what yours are, experiment. Don't be afraid to try new things and see what resonates with you, or see what other people are like, wow, I can't believe you can do that. Listen to them, listen to these kind of things and adapt, and you too will find your path to thrive in IT. So thank you so much for being with us. We will see you next week. We got a special one for you. See you next week.
Thank you for joining us for another edition of THRIVEcast. We truly hope you've enjoyed the experience and have learned a lot from it. Now, what we'd want from you next is to join us at thrive-it.com, where you can get subscribed to our multiple channels, get subscribed to our newsletter, and do more to get yourself to where you want to be in your career and your life in information technology. If there's anything we can do to help you, please give us an email at support@thrive-it.com. We'll see you next time.